So good morning, good afternoon, or good evening, based on wherever you are. So today, Krishna and myself will talk about some of the most critical supply chain decisions and how we can go about getting them correct, especially using anyLogistix. Yeah. So just a bit of introduction. So I'll just introduce myself and Krishna, and then we will introduce SimWell and what we do, and then we'll dive into the the webinar topic, which is 5 most critical supply chain decisions and how to get them right. So my name is Amit Kumar. I work as a director and lead the team in India. Basically, India operations I lead. I have close to 15 years of experience, mostly doing modeling, optimization, simulation modeling, and I've worked across various industries, CPG, supply chain, mining, steel manufacturing, discrete manufacturing, precious metals, etc. I have an electronics engineering degree from NIT Rourkela, and post that I've done an MBA in operations and supply chain management from Mumbai. My colleague Krishna here works as a senior architect, senior solution owner at SimWell. He also has close to 14-15 years of experience. He's an expert in supply chain planning, has seen multiple planning softwares, also like demand planning, sales and operations planning, and expertise wise, again, optimization modeling, simulation modeling, machine learning, AI modeling. Again, worked across various industries. He's also an engineer, mechanical engineer from Osmania University in India, and MBA in operations supply chain from IIM Mumbai. Yeah, Krishna, next slide. We can go. So again, the next few slides will talk about SimWell and what we do. But within the supply chain context or supply chain applications, there are 3 primary areas where we focus on. First one is supply chain design, which is the traditional supply chain network optimization, where we answer questions like if we are looking for a greenfield analysis, then where the facilities should be located, could be factories, could be a warehouse. What should be the optimal flow from one location to another, like which product and what quantity should flow in what period. And then inventory related questions like where should we stock products and how much. Associated analysis is related to, if there is a seasonality, then pre-build of inventory, when should we start so that we don't have enough capacity to meet the seasonal demand, but we are able to meet because we are building inventory in advance. Cost to serve analysis, cash to serve analysis is something we'll delve into a little more detail in the subsequent slides. And we can analyze the impact on the environment, like the CO2 emissions and so on. So those are related to supply chain design decisions. We can do within four-wall analysis also, which is like a warehouse planning. So again, a critical part of supply chain. So what should be our storage strategies? How many docks are required? What kind of storage systems will be used? So this is a more detailed modeling. In the past, some of our clients, these are the questions that they have gained answers to. Trying out different storage retrieval strategies, trying out different storage systems. And with the advancements in technology, moving to an ASRS, how much benefit will that provide? AMRs, AGVs, modeling, and so on. And then how many equipments are ideal, including staffing, like what should be the staffing level. Moving on to the last mile operations. So basically route optimization. Again, what should be the best route? What should be my fleet mix? The roostering of the staff and planning for deliveries. So these are the primary questions, supply chain related, applications where we have helped clients in the past. Again, at SimWell, we our primary focus is modeling, simulation modeling and optimization modeling. And then the next step is basically creating a digital twin of the operations. And the allied fields are data engineering, basically. How do I get the data which feeds or runs my model? So that also expertise we have. And again, as I said, allied fields like data science, analytics. So many times we have to do some predictive modeling, which will feed my simulation or optimization model. Like typically you can understand is the forecasting. So forecasting is something which drives the supply chain, and that requires analytics, various models and so on. Moving on. Yeah, I think this is the final slide about SimWell. So we are a world leader in simulation modeling. Currently, we are more than 80 team members, different skills. The map here shows how our team is spread out. So we have most of our folks in North America, USA, and Canada. We have a team based out of India. Krishna and myself are based out of India. We have a team in Australia. So, pretty much spread across the globe, across various uh, time zones. Multidisciplinary, multi-skilled team, so that we can build whatever it takes to create, a digital twin at scale. And you can see some of our marquee customers. Suppose the list is not complete. And yeah, I think next slide. And about anyLogistix. So anyLogistix is basically a tool developed by the AnyLogic company, which also has another product called AnyLogic, which is a purely simulation based simulation platform. anyLogistix, on the other hand, is focused on supply chain modeling and simulation. So it has a network optimization engine, which is essentially like a Cplex running in the background, which does the network optimization. And on top of it, it has a full-fledged simulation engine, which is, if I can say, that is kind of the uh, strong point of anyLogistix as compared to other tools. Like the backend simulation engine is actually the anyLogic engine. So you can optimize your network and then also simulate it using all the variations in the supply chain and all the disruptions, and study how your supply chain will perform. And we'll look at the digital twin concept and try and understand how that is going to help in your supply chain. So we'll try and define or explain what a digital twin is. So on the x-axis, we see time, and y-axis is essentially half of it time showing, okay, this is the real world. And then we create a virtual representation of the physical supply chain, which is our simulation model. And now what we do is we initialize the simulation model with the current state of the supply chain as the real world. That is the purple arrow which you see. So current state snapshot. And then we run this simulation model, and it can predict, essentially using the dynamic simulation engine, it can predict what will happen 1 week, 2 week, 4 week into the future, and so on. And then we see the impact on our KPIs that will happen. And using that, we can take some kind of actions which will basically improve our KPIs. And then those decisions I can go back and implement in my current state, which is the current time. Now, this kind of a communication between a real state and a virtual environment, when that is established, and a two-way communication again, one is sending information to the virtual model, and the second is doing analysis and taking recommendations from the virtual world and implementing it back in the real world. When that is possible or that is done, that is when we say it's a truly a digital twin of the supply chain. And how often this should happen? So that can be some trigger event based or periodic. So that is flexible. And yeah, in this slide, we show kind of the same concept in a maybe a more detailed way or a different way, I would say. Basically, in the center is your simulation model of which is the virtual representation of the supply chain. And then it is getting fed by three different types of information. The first one is mostly coming from the ERP system, which is what is the production plan in different factories, current inventory levels at different locations, how is your raw material supply plan, and so this is the data part. What is my current situation in terms of uh, data and production plan and so on. And then there is the business rules, which is more like what is the replenishment policy. And we can have different replenishment policy for different products. But all this information is also needed for my simulation engine to accurately represent the real system. So we will have replenishment policy, sourcing rules, transportation policy, and so on. But these information are kind of static. Uh, what is driving our supply chain is obviously the forecast or the demand sensing. And how is this different? Like demand sensing, I'll just try and explain. So basically, forecast usually we do at more of an aggregate level. But when we say demand sensing, we are trying to be more granular, and granular in three dimensions. The first dimension is, let's say, the location. So instead of forecasting at a macro region level, we try to forecast at a more granular level, maybe at each retailer, let's say. And then another dimension is SKU. So instead of forecasting at a SKU group level or some SKU type level, we want to forecast at a SKU level. And the third dimension is the time. So usually forecasting, maybe we do monthly basis, but when we say demand sensing, we are trying to forecast at a weekly or even a daily level. So that is again an input that goes into the simulation model that will drive the simulation model that, so the demand will be consumed and the rest of the system will basically propagate. The third kind of input is, which you see coming from the top, which is and with the demand, actually, there is also one more thing. The demand variation is also there, like the accuracy of the demand. So we also study different scenarios based on how accurate the demand is by running different applications. Then coming to disruptions, these are something like a facility shutdown. So in the recently, like we were working for a client and there was a fire at a factory. So factory is closed for a couple of weeks. So how does that impact your stock levels and service level basically? So something similar could be a lane closure because of some inclement weather event, some particular road is blocked. So now vehicles have to take a longer route, let's say. There could be production losses, which means basically some because of some either machine breakdown or some incorrect setting, I got more rejections. So I expected, X amount of product based on the past yield, but I got maybe 0.6 times of X. So these are certain disruptive events which take place, and then our simulation model, if we are able to give that input, then it can tell us the impact of that. So once these three kinds of inputs are there, we run the simulation model and we see, okay, what will happen, in 3 days from now, 5 days from now. So where our stockout will happen, when it will happen, and for which product, that it is able to predict. So that much is the digital twin concept. Now we can go a little more advanced stage, which you see on the right, like the AI brain, which you see. Basically, here we are trying to say that the AI brain kind of understands the output coming from the simulation model in terms of what it is able to predict in the future. And for example, if my objective is to minimize the out of stock instances, then it can see where the out of stock is happening for which product, and it can suggest some corrective actions. The actions might be, expedite the shipment or do an inter-warehouse transfer. There is no stock here, but there is excess stock in some other location and so on. So it's usually a reinforcement learning or some other AI-based engine which is able to interact with the digital twin and then suggest. And this suggestion can then be basically the prescriptive actions that, okay, this AI is recommending, do this action and your service level will improve or will be maintained. And we'll see one use case related to this, which is how do you make your supply chain more resilient, or how do you first of all measure how resilient your supply chain is, and then next step is to improve. And anyLogistix provides us the capability to create a digital twin kind of out of the box. It has the capability to integrate with ERP systems, various ERP systems. We can even connect it with an IoT uh, kind of data. For example, your last mile operations, your trucks, or even the movement between, let's say, a factory and a warehouse. So where the truck currently is and how much time it will take now to reach. So that information we can get from an IoT system. It has interactive maps, like you can visualize your supply chain in a map and see the connections and so on, which are typical, network optimization related outputs. So yeah, again, a very strong tool which helps us create a digital twin. Yeah, so now we will go to the 5 key supply chain decisions or drivers. So first one is basically the geopolitical influences, and this is something which is we are seeing in the recent past. Basically, US is increasing the tariffs for products coming from different countries. So what will be the impact of this? So if you have a supply chain network using anyLogistix already, then it is very easy to test out what will be the impact. And the various other geopolitical situations, like if there is a war, then and your supplier is affected, like in that region, then we can study, okay, if this supplier my lead time suddenly goes up, or even the supplier is not able to supply, then what impact we will have. Moving on to the other key decision related to regionalization and localization. Now, this might be related to the geopolitical influences in a way, because maybe one of the outcome for having high tariffs is that now companies want to manufacture more in the US, or at least close to US, as compared to East Asia. But if you look at the year around 20 years ago, we were talking about globalization, that make your supply chain more efficient, try to produce in a place, or even your suppliers, like try to get from wherever in the world we get the cheapest and good quality product. So the supply chain tended to be long and spread out. Now the impact was that now they were also very not very resilient and basically prone to disruptions. So we saw this during the COVID time, basically, because of various restrictions in different geographic areas, the uh, supply chains were not able to perform. We saw this during the Suez Canal blockage. Many products were not able to be shipped on time. And also the uh, natural calamity kind of event which happened in the Taiwan area, basically there was a huge shortage for semiconductor material. So from that, the trend has been to basically regionalize and localize, have your supply chain in a more closer, geographic area. So countries are forming regional trade blocks to strengthen the supply chain and so on. The focus on working capital optimization has always been there, and that is one of the out of the box solution which we get from anyLogistix, which is the uh, cash to serve analysis, basically. And my colleague Krishna will take us through that in more detail. But yeah, basically around where your capital is tied up and how you can uh, reduce your working capital, reduce time between capital investment and revenue collection, now optimize inventory levels, and so on. increased volatility and uncertainty. So this has always been around. Basically, this is related to, let's say, lead time variation. So inherent variations as well as disruptions. So in the recent past, we have seen more disruptions in the supply chain, but it could be as I already talked about. Maybe a factory is not able to produce. Maybe there is some strike and a warehouse is not able to operate. And then there are obviously inherent variations in demand. So a supply chain network optimization will always work with a given demand number. But if you are able to also simulate after doing the network optimization, then you can analyze what will be my service level given I have this much, demand accuracy, or the lead time variation is this much. So we can actually run multiple scenarios, and every time it will sample a little bit different demand, little bit different lead time, and the output that we get will be more accurate. The last one is, again, in the recent past, we have seen more focus on making the supply chain more resilient. Now, the previous point, which is related to volatility and uncertainty in the supply chain, is kind of related to focus on resilience. So that is the cause for making supply chain more resilient. But here we have to, first of all, be able to define what is resilience. We have to be able to measure in a way how resilient your current supply chain is, and then try and take steps to make it more resilient. So you have to measure it, and then through actions and analysis, basically, we make it more resilient. And even though there is a disruption, my performance level or service level does not get impacted that much. And we'll see in subsequent slides, basically, how we can do that. Essentially, for each of these points, we will go through one by one, a couple of slides for each point, and understand basically how to do that. Yeah, so I will basically hand over to my colleague Krishna to take us through the other slides while I'll continue trying to answer some of the queries. Yeah, Krishna.
Thank you, Raman. Good morning, good afternoon, good evening, all. Till now, Amit has spoken about what are the factors that are influencing those 5 key supply chain transformations. And before going into the transformations in detail, let's try to understand why a digital replica, or why a simulation and optimization with so much advancements in AI and predictive analytics. Still, simulation and optimization play a crucial role in evaluating each of the strategies on when we are making decisions. So when it comes to geopolitical influences, when we take trade dynamics, we have AI and ML that can very well predict the associated risks. But when we try to evaluate the cascading effect of those risks across the entire network in a dynamic environment, we need a simulation or an optimization or a digital replica to evaluate that, because there will be multiple interaction effects, and we will not be able to predict them with rules. And for scenario testing, if once our supply chain gets impacted through any of the, suppose if I take example of tariff. So if we want to evaluate alternative sourcing strategies, and we want to have our plants in different geographies and want to evaluate which is doing best, or like which sourcing should I consider. For that, we need an optimization or simulation to evaluate that. And when it comes to policy changes, once a policy changes, AI can flag the risk, and it can tell us immediately on of what is the likelihood of the risk. But when we test mitigation strategies, like again the same thing, evaluating different sourcing or shifting our facilities, or if we want to reroute our shipments. For all those things, we need a digital replica, an optimization or simulation to evaluate how our strategy is working. Same thing when it comes to regionalization or localization. AI can predict which based on the OTIF and based on the supplier scores based on the quality. AI can predict which local suppliers are best. But when we try to assess the trade-offs, if we try to simulate the behavior over supplier behavior over long term, and we see what is the cost versus lead time, and what is the capability of my supplier. If I have a surge in demand, would my supplier be able to supply me the material that I'm looking for? So the risks, the cost versus lead time trade-offs, for evaluating those, we still need a simulation or optimization. And also to evaluate capacity constraints. So we have done regionalization. We have got some factories at regional level. Now, 5 years down the line, we expect some trend in demand, and we predicted the demand through our MLA algorithms. But like, what would be the impact of it? Will our current manufacturing facilities, warehouses, will they be able to cope up with the demand? Will they be able to supply without disrupting, without impacting our lead times? So to evaluate that, again, we need a digital replica. And again, the last one, to evaluate different strategies, solutions, we need a simulation or optimization. Again, when it comes to working capital optimization, AI can definitely predict the cash inflows, cash outflows. But when it comes to the time, suppose if my customer delays payment by X amount, or if I differentiate my payment terms with my supplier with certain by X days, how would it impact my supply chain? Would I face any liquidity crunches? Would I face any delays in terms of what can I produce and deliver? So to understand this cash to cash cycle, if we bring time angle again into consideration, then a simulation would be the one which helps us to evaluate our network across the time periods and see like where we are getting impacted. And same with credit and payment terms. AI can use the historical payment terms, payment behaviors, and kind of flag the suppliers and predict few things. But after predicting that there might be some impact on specific cash flow because of historical payment behavior, what would be the impact on my supply chain? How would it cascade till the downstream? To evaluate it again, we need a simulation. Same thing with multi-echelon trade-offs. AI can optimize our inventory at a single node. But to understand what is the impact of that optimization, I have reduced my inventory. I have made a just-in-time inventory. But what would be the impact of it as soon as I got a tariff add announced? Like, how would my just-in-time inventory perform? It is not easy to understand it just through predictions. We need simulation to evaluate how the impact would be on my network. Again, volatility and uncertainty. We have excellent algorithms in machine learning and AI, where we can use the historical behavior. Also, we can use the future promotions, price sensitivities, and all, and can predict the demand. But there is volatility beyond demand. What if there is my supplier failure? And what if demand of a specific product increases in a specific region? How would that region gets impacted? How would I plan transferring certain stock from other regions? If I transfer, what happens to the other regions? To evaluate the entire network, impact on the entire network, we again need simulation to do that. And when it comes to anomalies like demand spikes, AI can very well predict that. And again, how do we tackle those anomalies? How do we tackle the demand spikes? We will have some strategies in mind. To test those strategies, we again need a digital replica, a simulation to do that. And finally, resilience. Again, AI can identify the risk. We can get the risk priority index, or like what is the impact of the risk. But given the risk, how should we mitigate the risk? When we do dual sourcing, we would be able to mitigate the risk, but at what cost? And like, instead of dual sourcing, if I have more stock, how would my supply chain look like? Where would I get better benefit? To evaluate all these things, we need optimization. Visibility, yes, AML can provide insights, but yeah, if you want to see the cascading effects, if you want to see the behaviors across different tiers in supply chain, how would disruptions impact across the tiers in supply chain, we again need a digital replica, and optimization can help us better in there. And again, when we do different recovery plannings, beyond AML, we need a digital replica to test these things. So we'll go into each one of these in detail I'll try to first define the things, what are the KPIs that are important, what would be the levers that we can use, and then at a high level, we see how we can implement it in anyLogistix. So what are geopolitical influences in terms of supply chain? I try to put the definition at a very high and simple level. It can be more detailed, but at this point, if we see, there are kind of policies or international political relationships which can impact the supply chains which are spread across the globe, which are cross-border supply chains. And they may even restrict the access to some of the critical materials or restrict access to some of the markets. And in that way, they can pose threats to our supply chain. What is it like? Given this is the definition of, given this is what is geopolitical influence, how does it impact the supply chain? So it can impact on the cost here we are talking about tariffs. With tariffs, we can have increased landed cost and it can squeeze our profits. And some of the players who are already localized, they might get a competitive advantage over us. So till the point when tariff was not levied, people who are supply chains which are global will try to source the materials from cheap labor or cheap material component regions, and in that way they gain benefit or like a competitive advantage. But as soon as tariffs get levied, maybe they become disadvantaged. So we have so that can be an impact on the supply chain. And the inventory models which are supposed to be the best earlier, just-in-time models which try to minimize our inventory levels and try to minimize our capital locking, might not be the best inventory strategies anymore, because if tariffs come in, frequent shipments might create a lot of disruptions. And when it comes to, this is not an exhaustive list of KPIs. I have, for our understanding, I have listed some set of KPIs. When it comes to cost KPIs, we can, to evaluate how well our supply chain is performing, or to evaluate once we have a strategy in place, how well our strategy is able to handle this tariff now. Some of the cost KPIs could be like landed cost, the cost after the import, any savings that we are doing on duty. If we are in a low tariff, if we are importing from a low tariff region, what kind of savings are we doing on the duty? If we try to absorb tariff by ourselves, what would be the percentage, what would be the revenue impact? And like if we want to change our inventory policy, we want to stock more now, like what would be the impact on the inventory carrying costs? And if you want to evaluate if you want to evaluate having new plants, localized plants, or new localized assembly points, if you want to expand our supply chain footprint further, what would be the impact of fixed variable overhead costs that are related to these facilities, or the sourcing changes that we make? While those are the dollar level KPIs, when it comes to service level KPIs, every time we import, there might be lead time impacts, because due to clearance, it might get stuck at the ports for some more time. And there can be lead time impacts on sourcing changes, because maybe we are sourcing from a nearby region till now. Maybe we have to source from a farther region because the farther region is having less tariff now, or it can be vice versa. Average inventories and stock out rates, how our inventories are. Like if we kind of restock all the quantities, like how our average inventories are performing. Are we did we overstock, or like if we are still following lean inventory models, like how to what extent are we getting stockouts, and also the service level impacts, how are our service levels getting impacted. So some of the levers I have defined here. When it again, this is not the exhaustive list. Each company can pull a different lever, but I try to give a general. I'm trying to give a general idea on like what kind of levers we can use to tackle a geopolitical influence. So some of the levers can be we can change the product mix. Maybe we can if we are importing from a country on which now we have got a very high tariff, and like maybe we can change the product mix. Instead of importing a product X, maybe we can import product Y which has less tariff. So we might change our product mix. And we can also change the sourcing percentage. Maybe that is a crucial supplier. Maybe we can consider that supplier to be a backup supplier now. We can still source from them, but maybe sourcing percentage can be changed from the tariff impacted countries. And we can spread we can play with our suppliers and sourcing. We can evaluate suppliers and sourcing from different regions which are less tariff affected or which have lesser tariffs. We can play with our site capacities and flexibilities. Maybe we do not need to produce at a low, maybe we do not need to introduce new sites in low tariff regions, but maybe some of our facilities, if they're already in low tariff regions, we can see to what extent we can produce more in those sites, and whether they are flexible enough to produce different kinds of products or not. We can even evaluate, we can even pull that lever and see how it works. And we can introduce new facilities at strategic locations and see how it impacts. And we can also play with stocking strategies. If we see tariffs will not last long, rather than doing the costly network changes or even negotiating with suppliers on the different product mix or sourcing percentages, we can quickly stock more for the duration of the duration that we feel is short and it gets impacted, and see how, and we can pull that lever as well. So here in this webinar, I will try to cover at a very high level what is the flow in which we can model our strategies in anyLogistix. While this one shows only in one direction, the flow chart only is in one direction. It's a circular implementation where we kind of evaluate certain strategies and then see if our strategies are working well, if we are getting, if they are aligning with our objectives. If not, we kind of circle back and evaluate different strategies. There will be detailed webinars on each of these topics where we go into the details. We also demo specific models on how some of the strategies can be implemented in anyLogistix. But in this, we keep it at an introductory level, at a very high level. So to start with, we can design our baseline network where we create our customers, our goods, factories. We define all these things, our warehouses, we define our network, we define our costs, we define our constraints, and we build the base model in anyLogistix. And once we build the base model, we evaluate how our baseline performance is, and see like what is our current revenue without the impact of tariffs. How is our current revenue? How is our current profitability? How is our current supply chain performance? And then we can add tariffs into the system. Like Amit said earlier, anyLogistix comes with directly with out-of-box solution to add tariffs to the system. So you can add between HS codes, you can add a tariff as a percentage of product cost, or you can add it as a fixed tariff, or you can add it as a mix of both. Once we add tariffs, we can see like what is the impact of tariffs on our supply chain. Then comes if we want to do any network changing, if we have any strategies that are related to network changes, not simply policy changes or inventory changes, but which are related to the network changes, then we can list down those strategies, maybe shifting our facilities to a free trade zones, or localizing our production, or splitting our source and diversifying the sources, splitting our sourcing. And maybe shifting our final assemblies. Maybe we manufacture still at the same place, but before importing it to the final warehouses or regional warehouses, we do final assemblies in a low tariff country, and so that we label it as produced in low tariff country. So any network changes we can do, and anyLogistix can also help in identifying what is the best location for these network changes using GFA. And once we decide what will be our network strategy, like well, if we want to add any of the new facilities or new warehouses into the system, then we can update our network accordingly. We can update the costs. Now, since we are introducing new facilities, we will add new costs, fixed variable overhead costs and all, and we also add specific constraints that we want to add on top of those facilities. Maybe we do not want those facilities to supply to every place. So whatever constraints we want, we will add them. We also kind of do regional groupings because to evaluate some of the scenarios, like I want to zone a specific demand, and I want only specific facilities to supply to that zone. So for that, first we have to do the groupings in the network, and then we evaluate new connectivity. And so once we have all the nodes, we kind of connect the new nodes, and we kind of determine which products can be sourced from those nodes. So connectivity will restrict which nodes can be connected, and sourcing will restrict, given this is the connectivity, what products can be sourced. And then again, since we have added new facilities, if there are any new tariffs that maybe we have moved to a low tariff zone, not entirely no tariff zone. So what would be the tariffs on those sources? We can add them. Once we finish the network as per the new strategy, we can evaluate different scenarios. So we can check different product mixes and see like which product mix is working best, or we can leave it to the optimizer. Say I'm free to produce at facilities XYZ. Now you tell me what is the best production mix I should use, given this is the impact of tariffs. And we already spoke about demand zones. And for certain non-critical products, we can even evaluate what are the different transportation modes. Do I need to always ship by air, or can I ship some of the low priority products through sea, and I can save some of the transportation costs in that way. And we can even evaluate different inventory policies. Once we create multiple scenarios for each of the strategy, we can compare the KPIs and see and decide which scenario is performing best. If you want to evaluate more than one strategy, we can again circle back, plug in a different strategy, and we can continue this cycle. And then at the end, we can decide how is the impact and how would we evaluate. I'll go to the next challenge, that is regionalization or localization. Again, what do we mean by regionalization? Where it is nothing but we are reconfiguring our supply chains, maybe from a globalized supply chain to we want to bring our supply chain to more regional level concentration, where we concentrate our operations only at a specific region or only in a particular country. What are the benefits in regionalization? Based on whatever we are seeing recently, it will reduce the exposure to any kind of geopolitical events. Once we are regional, our exposure to tariffs, sanctions, and bans will be reduced. Our supply chain will be more resilient. Suppose Amit spoke about earlier about these disruptions. We are no more bothered about Suez Canal disruption or typhoons or pandemic, because we are local, and we don't have to bother about the fragile global logistics. We will be more cost efficient because we will be sourcing from the nearby suppliers and nearby production facilities. So we will have better transportation. We will have improved cost efficiency, and we don't have to bother about regular compliance, and we don't have to first create a generic product and then label it as per the country standards and all that. So all those kind of issues will be resolved, and that is why some of the companies are prone to regionalizing their supply chains. When it comes to KPIs, I'll try to be a little faster. What would be the total cost to serve? What would be since we have regionalized, some of the costs might increase, our labor costs might increase. Maybe earlier we were trying to get the production from places where there is high labor efficiency, but now it might be changed. Our transportation costs, how our fixed and overhead costs will change. When we regionalize, are we getting enough locations where we can put our facilities, and are we having better fixed and variable costs, and how are our inventory carrying costs? Maybe this is the time when instead of maintaining high inventories, we can go to just in times, because we are all, we have everything regionalized. And we can also see as supply chains go to sustainability, even the CO2 emissions will be less, and we will have better CO2 impacts. When it comes to performance KPIs, we can see the lead time impacts and how responsive the supply chain is. To what extent did our OTIFs, on time in fulls, have improved? How our inventory is now? Are we having more inventory turns because we try to reduce our inventory, the amount of inventory that we will be holding? And one important thing is now we have regionalized. We have come to localized facilities, but are our facilities capable? Are our facilities scalable? Given 5 years down the line, 10 years down the line, I expect surges in demand. Will our facilities still be able to cater to the demand? Is one thing which we can evaluate. Some of the levers, again, suppliers and sourcing ecosystem, we can evaluate the regional supplier and sourcing ecosystem, and like if we get it, then that is one lever that we can pull to first regionalize. We can play with our, again, same thing, site capacities and flexibilities to see if our regional sites can cater to our demand. If needed, if we are already very much globalized, and if we don't have any regional facilities, and we want to introduce some of the regional facilities, then we can play with the new facilities and see how the new facilities are impacting the overall performance. We can again play with stocking strategies. Maybe we are earlier maintaining more inventory. What would it be if we now reduce the inventory and maintain lean inventories? And we can even evaluate our distribution model reconfiguration. Maybe since from globalized level, we are coming to regional level, maybe we can evaluate some drop shipments feasible? Can I directly ship from my manufacturing facility to my customers? Do I still need a hub and spoke? Do I need extra hubs or facilities for that? Or can I use my factory itself as a kind of hub? So we can evaluate, we can even reconfigure our distribution. So I'll slide through fast here. Again, we create our baseline network and we evaluate our baseline performance. Assuming we are a global supply chain trying to regionalize, if we want to have any network changes, if we want to use existing only regional facilities, do we need to increase their capacities, or do we need to add new facilities at strategic locations instead of using existing facilities? Maybe existing facilities were not configured for efficient regionalization. Maybe they were near the ports because earlier we were getting the global supplies to port, and we wanted to make our logistics efficient and kept our facilities near ports. But now, what would be the better strategic locations? And we can even relocate our facilities if needed. And for that, again, to evaluate what is the best facility locations, we can either use GFA, or if we already have the locations predetermined, we can do the network changes accordingly. We can again update all the things, the costs, the connectivity, the CO2, any groupings that we want to do, any demand changes that we expect. Now we are regionalized, maybe our demand will increase, or like we expect a slow growth, or we expect a decline because the customers will, because the sourcing change, maybe the customer trust might go down. Anything, we can even do the demand changes, and like we can add the distance and lead time constraints. Maybe we wanted to be more agile, more performance-driven supply chain. We wanted to quickly deliver the products, so maybe we kind of constrain that certain facilities can only supply to certain regions, so that we can be more faster in supplying. Again, we evaluate different scenarios. Some of the examples, maybe we evaluate a completely regionalized completely regionalized supply chain, how it looks, versus maybe we keep it hybrid. Partially we will source from global level, and partially we do from regional level. And we can evaluate different sourcing and relocation strategies. Like I want to source everything from regional versus I want to source something from regional and something from outside, and we can evaluate different inventory policies and parameters. I would write first, I'll decide what policy is best, and then I'll decide what would be the parameters for the policy. And we compare the KPIs, and then we decide the impact. Then let's go to working capital optimization. Nothing but in anyLogistix, we call it as cash to serve. So it is a hybrid. Traditional cost accounting doesn't go into the details at every stage in supply chain. So when it comes to cash to serve, it goes to every detail in supply chain. And when we are optimizing the supply chains, traditionally we majorly focus on operational efficiencies and costs, but we still evaluate the costs, but we do not evaluate the complete financial dimension. So working capital optimization is a mixture where we kind of evaluate not just cost flows, we also evaluate the cash flows and try to optimize the supply chain, not just for cost, but also for the working capital. So what kind of impacts it have? We will have a better cost transparency. So first thing is we can break down the cost into at a highly detailed level, and we identify areas where expenses are high, and with that we can decide which areas to continue, or like which customers to. Again, it improves the profitability. So this is where we can identify which customers are profitable, which products are profitable. Do I need to continue with all customers and products, or can I kind of segment and decide only I can go ahead with few customers and at a high service level, maybe some customers at a moderate service level. And we can accordingly reallocate our resources. Maybe we can invest our time and energy on the segments which are more profitable. When it comes to the KPIs, what is the cash on hand that we have? What are the loans and interests that the organization has? What are our payable and receivable terms with the suppliers, and are our current accounts payable and receivable terms making sure that there is enough liquidity in our supply chain which we can use enough? And like, what is our revenue, what is our total cost, what is in profit loss statement? We can evaluate all these dollar related KPIs. And when it comes to supply chain performance, again, how efficiently am I fulfilling? What is my motive? What is my service level by product, especially when it comes to key products or key customers? Are we providing a good service level to them? How are my lead times? And how is my inventory efficiency? The worse the inventory efficiency, the more our working capital is going to get locked in the product which is being stored. The less liquidity we will have in terms of and the less liquidity we have, the less freedom we have to operate the supply chains. Again, the levers, the first thing we already spoke about, we can segment our customers and products and focus on like high performing customers or products which give us better profitability. We can even evaluate, we can play with our payment terms and discounts. We can say, what if I change my payment term? How is it going to impact the liquidity in supply chain? How is it going to impact the overall supply chain performance? In the same way, what if I provide discounts to the customers who pay very quickly as soon as they get delivered? If I provide discount to those customers, is my revenue improving? Because finally, am I getting more sale? And because of that, am I also having enough liquidity? We can evaluate that. And like, how are my stocking strategies affecting the liquidity? Am I having enough working capital, or is my capital getting locked? And again, same thing, distribution model reconfiguration. The faster we deliver, the faster we convert it into cash, the faster we will, the better we will have as working capital. So again, anyLogistix has out-of-box solution for this. We don't have to brainstorm on how do we do working capital optimization in anyLogistix. It has very good KPI visualizations. Also, it has good tables or good input data where we can input our the details. So we and can straight away evaluate how well my working capital is, how good my working capital is looking. So for this, again, we create a baseline network. We define all possible costs. So all the fixed costs, variable costs, storage costs, transportation rates, everything we define. And then this is this is out of box feature where we can define all our cash flows. What is the cash on hand? How is my loan? How are my loans, and what is the interest? How are my account payable and receivable terms with my how are my accounts payable and receivables? How are my payment terms with the supplier? So we can input all these details in the network model, and then we can simulate the network. We can see how good the baseline performance is. Like we can, again, like I said, we can see what are the largest sources of tied up capital, which customers and segments or regions are most profitable for us. Maybe understanding this will make us rethink on like how we need to change our policies to realign our supply chain to serve these customers and products better. So usually we don't need to optimize this network, but maybe if we want to optimize, we can use we can again go to GFA and we can identify the new facilities, optimize the network before simulating it. And then we create different scenarios. I extend my payment terms with my supplier. Now, how does my working capital look? Or we already spoke about this. I give some discounts to my early paying customers. How does my supply chain performance health look now? And I reduce my inventory. I keep a minimal inventory. Is my liquidity being more now? And we run multiple replications, and then we compare the KPIs. And finally, we can decide or go ahead with the strategy that we feel is best to have enough liquidity. Then is the volatility. So I hope I'll try to cover it very fast. And I hope it's okay if we extend the webinar another 5-10 minutes. I'll try to just go faster, and we can have any answers. If anyone has any questions, you can post your questions, and Amit will be able to answer them quickly. So volatility, as we all know, it's kind of unpredictable variability that we see in our supply chain. Mostly here we are speaking about demand volatility, but the same thing can happen in lead times, in our supplier availability, and all these will kind of disrupt our regular supply chain behavior and can create problems. When it comes to operational challenges, we might have stock outs, excess inventory, or even maybe a disruption in a plant can halt our production. For this, in order to expedite our shippings, and because we are having high demand and we are not maintaining enough inventory, or to have any penalties because we are not able to fulfill, so we incur higher costs. And given we are not able to perform well, we might have reduced customer trust and even market shares. So some of the KPIs that we can evaluate, given our demand has surged, if we are not maintaining enough inventory, like what is our expedited shipping cost? Or because we see some volatility, we try to have additional vendor managed inventory as well as the higher safety stocks and all. Then we can see what our inventory cost is behaving, and what is the revenue loss given if we lose our customer trust, or if we are not able to fulfill all the orders, and what is the production cost given we have disruptions, we might have to produce more, and what is our time production cost looking like. Now, when it comes to performance KPIs, again, on time in full, how is my order full rate, how is my back order rate, is my inventory still efficient, and how frequently am I stocking out given the spikes in demand. So the same kind of levers, we can play with the production and sourcing strategies. We can do product portfolio management, where we can try to standardize the production, so that We have the same set of components. We have a standard set of components which we created and kept with us. As soon as the demand comes, we assemble them and give them to the supplier. So postponement might help. We can evaluate multiple stocking strategies. We can tackle the demand spikes with pricings and promotions. When there is low demand, we can provide promotions, and when there is high demand, we might increase pricing to tackle the demand. And the final one we have been seeing, reconfiguring our distribution model. Again, for this, we create a baseline network. We add variabilities. So either it's a lead time, or either it's demand, or either it's handling time, anyLogistix has capability to input them as distributions, not as single point numbers. So we can add distributions to all these things, and we can configure demand volatilities in two ways in anyLogistix. One, we can use one of the tables and say the demand coefficient has changed now. The entire aggregated demand is spiked. So how would it impact? Or we can choose a specific customer, a product, or a group of customers, a specific region, and a combination of products, and say the demand for this combination has spiked now. And we can do demand sensing and demand variability as well. So we can also add variabilities to the demand. We can configure demand sensing distributions rather than static numbers. Then we evaluate the baseline performance. Usually we don't need to update the networks here when we evaluate scenarios, but if we need a network update, we can do that. We can optimize our network, and then we can evaluate various scenarios. So how resilient is my supply chain to varying levels of volatility? My demand spiked 1.5 times, my supply chain is resilient. What if my demand spiked 2 times? Am I still able to supply all the demand, cater to all the demand? Or do I start incurring back orders and losses? So the impact of demand shift between distribution channels. Maybe I have designed my supply chain more for a brick and mortar delivery, but now with rise in e-commerce, my supply chain is shifting towards all my demand is shifting towards e-commerce side. So am I still able to fulfill, or do I need to reconfigure my supply chain accordingly? Different sourcing policies, given the demand spikes, maybe I will not go with the traditional sourcing. I'll see whatever is the fastest, and I'll go with that, or I'll split my demand across multiple upstream nodes. And we can even test different inventory policies. I'll keep more stock for high demand products. I'll stock at regional warehouses. For low demand products, I'll stock at the central warehouse, or I'll stock more at certain points and see whether it whether it is tackling or able to fulfill the orders. Then we again run multiple replications, because we have given distributions as inputs in order to make sure that we sample all extreme cases, as well as we sample or we kind of represent the actual demand variability and all actual variabilities. We run multiple replications. Then we compare the scenarios, which scenario is performing best, and then we finally decide. When it comes to resilience, we all know this very well. The impact on supply chain because of any kind of black swan events or natural disasters, and this can have major impact on our operations. And if there are like restrictions and all, we might not be able to meet our customer expectations. Then it becomes challenging for the supply chain. Again, when it comes to operational challenges, if we got impacted by maybe at a production site, so we might not be able to do the production at the state. So the production gets stopped, and our capacity is gone in waste. Our resources, we do not know what to do with the resources, so we encounter productivity loss. We can financial wise, we will have increased costs, revenue loss. Even we will margin will erode, because once the disruption is over, we might have to work overtime, and like whatever margin we are getting, we might have to pay more. Whatever margin we are getting might erode, and we also need to expedite our shipments. There also the margin we are getting might erode. And again, strategic wise, we can lose the market share, we can lose the customer trust. So the KPIs, some of the KPIs I listed here can be like the recovery cost. What is the cost of our recovery? what is the cost of overtime production, what is the cost of expedited shipments, and what is the cost of lost sales, what is our revenue loss because of lost sales as well as because of reduced customer trust and reduction in demand. And some of the performance KPIs we can evaluate is what is my time to survive once my facility got disrupted, to till what extent I can survive. What is my time to recovery? Once I lost survival and I'm going to either back orders or lost sales, what will be the time it takes for me to recover to my normal performance? And what is my order fulfillment stability? Given there is a risk, is my supply chain resilient enough to fulfill the orders? To what extent am I fulfilling? Risk exposure index, to what kind of disruptions is my supply chain being is sensitive? Is my supply chain sensitive to specific kind of disruptions? What is that disruption matrix? And what is my supplier resilience score? To what extent are my suppliers resilient? Given there are disruptions, are they still able to supply whatever the critical components that I needed? Again, this is similar to localization. So the strategies or the levers would be similar. Changing sourcing strategies, or having a redundant supplier or redundant sourcing. Stocking strategies, given we predict events in the future, we can stock it, we can stock more. And we can play with multiple sites, so we can increase our site capacities and make our sites more flexible. Given one factory has gone down, I will be able to fulfill it from an alternative factory, and we can even have redundant facilities, redundant warehouses, and see whether that will help. Given my facility X has gone down, now I will start producing in facility by a redundant facility. Is it helping? To what extent am I correct the cost? So again, the modeling in anyLogistix is similar. We create the baseline networks,
So,
we evaluate all the network changes, we
Krishna, I think
evaluate scenarios.
we can answer
And then
some of the questions and kind of bring the webinar to a close.
Yes, Siddhant,
So
sorry for 10
maybe,
minutes.
and you can help me with some of the answering some of the questions, but I'll take some of the ones. Basically, one question is, can the region column in the location table used in any sourcing or tariff table, or do we have to define location groups? So I think yes, defining location groups is the way I would do it. Yes. Another question is, I'm already using anyLogic. Could you compare both tools? Is there anything you can model only with ALX? So yes, anyLogic does not have a supply chain network optimization engine. So ALX has network optimization, which is MIP based, Cplex based, solver based, and it also has a simulation engine. So the simulation engine in anyLogistix is the same, anyLogic engine in the background, but additionally there is a network optimization piece which you get. Another question is, what kind of sustainability?
Your point, adding to your point, the time needed to deliver the solution will be faster in anyLogistix if we are building a network simulation. In anyLogic, it might take more time to build the same solution.
Because this is specialized for supply chain. What kind of sustainability data can you consider for the simulation? Are there certain ESG risks that can be included or KPIs shown? So I don't think any ESG risks are supported. Only CO2 emissions we can model. We can define per unit how much CO2 is produced in transportation, in production, and so on. And what we can do is we can optimize on the CO2 emissions. So we can include it in the create a multi-objective optimization, considers cost, but also considers the emission. So it tries to minimize the emission, maybe at the expense of the cost.
You're muted.
Oh. Hello. Or can you answer, Krishna? You can see the Q&A. Can you hear me, Krishna?
Yeah. Maybe my connection is not stable. Yes.
Okay.
Just adding to Amit's point, when it comes to ESG risk, if we know the relation, given we know the relation, between the volume that is produced versus what is the risk, ESG risk we expect. We have custom constraints in logistics where we can say this is the variable that is going to come out, and like this is the, since I know the relation, this is the impact that it can have, and then you can add it to your objective function. That is an while it's not there out of box, you can model it in that way.
Right. Another question was, can you see one of the question? Basically, Jonathan is asking, can any logistics model tariffs separately from duties? I think only tariff table is there. To consider duties, maybe some custom constraints we'll have to add. What do you think, Krishna?
So I couldn't completely get the question.
Okay, so maybe
China to
we
USA,
can
but if
send the answer
China to
after
Mexico to
the
USA.
webinar.
Yeah, if we are moving from China to Mexico to USA, and if we see there won't be any impact of duty rates, won't reflect the China to USA tariff. Yes, it will not be straightforward, like Amit said, but yes, you can model it using certain constraints. And
okay. Yeah, another question was, can ALX conduct federated forecasting demand? Federated demand forecasting. So no. So basically demand forecast has to be an input for ALX. It can generate simple forecast based on some rules if you provide it, but it's not it will not do a very accurate forecasting for you. So forecasting usually we take as an input to my anyLogistix model.
you have periodic
simple forecasts
simple
we can give.
forecast. Yeah, if you have any variabilities that you want to add to the forecast, yes, you can. And logistics generates that. But if you have, like Amit said, advanced things with lot of trend, seasonality, and all that stuff, yes, you have to get it from outside.
Yeah, another question is cache to serve analysis based on simulation or optimization?
Simulation.
Yeah, this is simulation based.
Because you will have time, cache to serve will also have time impact. If I pay late, how would it impact? If I pay early, how would it impact? So the time angle will come in simulation.
Another question by Sukumar is, do we have a sample or example model for these scenarios? So for the particular ones we presented, we don't, but we intend to do subsequent webinar where we'll show a demo model for each of them. Then the last one again from Jonathan. So first of all, thanks, Jonathan. You also answered some of the questions. What about intelligent digital twins in ALX? Yeah, so basically we are using anyLogistix for creating the digital twin, and the AI part is additional, which we have developed like at SimWell. So that's not part of anyLogistix per se. Last one was, how do you define the risk exposure index?
So that you might have to do it outside depending upon. So you need to know your supply chain, and you need to have a matrix on which risk is going to impact your supply chain the most. Especially
so these are ways to measure your resiliency. So currently not out of the box from anyLogistix, but we can use the output to basically calculate it. I think that is all. I think I covered all of the questions. Yeah. Thank you.
Thank you all.